All right. And we will get started. So welcome, everybody. As you know, I'm Kathleen McGivney, CEO of RedBar, and I'm joined by Adam Kraniotis, the founder, and Adam Moore, our photographer. I will hand it over to Adam to introduce our special guest today in a second, but if you have any questions for the panel, please put them in the Q&A that you'll see at the bottom of your screen on your Zoom application, and feel free to chat amongst each other in the chat, but if you have questions for us specifically, please put it in the Q&A. And I will hand it over to you, Adam.
Thanks, Kathleen. Yeah, today we have our special guest, Joshua Shapiro, hailing from Los Angeles, California. He is the founder and the man behind the engine turning that he does under the name JN Shapiro Watches. And he was at the RedBar Global Meetup in New York last year on one of our panels there. And we're happy to have him here today to show us around his workshop and give us a little demonstration.
All right. Hello. Thanks, RedBar, for having me. This is super cool.
Thanks for joining us.
Yeah, we're all trying to figure out this Zoom thing. So please be patient, and I'll start giving a tour of my workshop. First off, Artur's here, socially distancing with me.
Hi.
Hello. I'll try to show some of his work soon. He's doing some cool stuff. So what I've tried to do is I've tried to put little signs on the machines, which helps understand where they come from. And like for any watchmaker, like the tools are everything. Like you can't make watches without tools. So all watchmakers are tool collectors, and I've got a lot of them. So first off, this is one of the most important tools in my shop. It's a Shaolin Lathe. This one's made in Switzerland in 1982, and a lot of operations making watches, dials, everything involves this machine. And then over here, Artur's making a seconds hand pipe, which is very precise operation. And what's neat, this machine is called 11 Lathe. It was made in 1992, and it was made right here in Southern California, which is super cool. And the company actually used to be in Culver City. So this one, you can see it was made in Culver City, about a mile from my house. The aerospace industry is huge in Southern California. So watchmaking companies turned into aerospace companies. Just like this machine is a little mini mill. It's also made in Southern California. This one was made in 1975. And this is a really important machine in the shop. This one's a pretty expensive machine, very important. This is a Haas Cnc Machine. And this is also made right here in Southern California. This is where watches are born in many workshops, along with all the manual machinery. Over here, we have the cool engine turning machines, like the really vintage, very industrial looking machines. Like the design of these really hasn't changed in over 150 years. This one's called a Neuweiler Engelsberger. Say that 10 times fast. Straight line machine. It's made in 1950 in West Germany, right after the war. And this is a plant rose engine machine. We'll be spending some time on this machine. This was made in 1930 in England, pre-war. I'm a history major, so sometimes I ever wonder if these two machines are going to ever fight it out or something. Okay, over here we have a fiber laser. This is for doing engraving and some machining operations. This one's from 2018, ring fiber laser made in China. And then I'm transitioning over to this new laser that I just built. This is an IPG 200 watt fiber laser. A lot of the parts come from Germany. And then we have our clean room over here. And this is where we do watch assembly and some precision operations. Like this is a pivot polisher made in Germany around 1970. Sights jeweling set, staking set. We use these quite a bit. You know, we're developing our own movement, and like something like this is, you know, like a very rare machine that not a lot of people know how to use. And one of the most difficult parts in a watch to make are the pivots. The pivots are the pieces of metal that actually revolve inside of the jewels. And those have to be polished and ground to the absolute perfect size to be able to fit with enough space inside of the jewel holes. And then this is a very modern tool, but I'm having a lot of fun with it. This is a SLA 3D printer made by Formlabs. I'm making all sorts of stuff with this. It's a really cool machine. All sorts of neat stuff here. Usually there's like a resin tank here that looks like goop. And from the goop rises parts that we make for the machine shop. For instance, I just made a part the other day that you know, took an hour to make on this thing, and if I had to buy it, it would have been $1,500. So that was pretty cool. Almost paid for itself. A few other things. Here's a UWD movement. Not assembled, but will be soon. You know, a micrometer for measuring very precise things down to the micron. Here's our toolmaker's microscope, also the same thing. You do very precise measurements. Yeah, it's the clean room. Any questions so far?
Nope, all good here.
Okay, you guys can hear me all right?
Yep.
Yes.
Okay. All right, so the next cool thing here is, this is my Rose engine machine. I'll be giving a little demo on it. And one of the hard things with video in Zoom is to show things with detail. But luckily, I'm doing a really cool collaboration with Atom Moore. He's sent me some prints that he's specially customized for engine turning. And together with his prints and my engine turning, we're gonna do and sell these. Some of the proceeds are gonna go to charity. And it's just a really cool, like, two different medias, you know, a print that he's photographed on top of a piece of aluminum that I've also engine turned, and just really neat. And it also happens to be kind of like a very large, perfect thing to kind of show how engine turning works. I can show you guys on a dial, and I will on another machine show some more intricate work, but this is kind of cool to see how the whole operation of the machine works. So I've got a second camera so you can kind of see the whole machine while I'm on it. And as I'm explaining things, I'll probably put this camera down, and you may want to switch to the other camera. Wait, but okay, I can see it's a little low, but I think while I'm sitting, you guys will be able to see it. So first I'll stay over here.
Okay.
And I'll explain how a Rose engine machine works. First, let's start with the thing that's most visible always on these Rose engine machines. You know, a lot of people, when they think of a Rose engine machine, they think of these rosettes. This is where it gets its name from. They kind of look like bronze flowers. They have these curves in them and these interesting profiles and shapes. And basically how the machine works is it copies the patterns from here onto your work surface. So you can see there's like a flowing line here. And you can see this guide is following this flowing line here. But one cool thing, I want to catch Artur doing this. I don't know if you can see this. he's using a drill that's about 0.2 millimeters, almost the size of a human hair, to make a post for a seconds hand. It's a very, very precise operation. Okay. All right. Sorry for the tangent. All right. Okay. So how the machine works is the whole machine bounces and moves against this piece and this rosette. So the machine is actually vibrating and moving and rocking, and it rocks exactly to the shape of this bronze rosette over here. And this cutter over here cuts the pattern, engraves it onto the metal. Now, I'm going to show myself doing a few cuts, not on this phone, but you'll be able to see it through the iPad. And then I'll bring over the microscope, which I have on a TV camera, and you guys will be able to see it up close. Okay, so go ahead and take a look at the other camera. I'm just going to set this here.
Okay, I've moved it to the other camera.
Oh, okay, cool. All right, thank you. All right. So one of the really neat meditative things about these machines is it's all hand operated. So my right hand is applying the right amount of pressure, which changes and kind of varies, especially with something like this cool print. It's not perfectly flat, so I've got to do a lot of the feeling with my own right hand to get the perfect depth of cut. And then my left hand is controlling the machine and it rotating. And I just try to do that at a good, solid, even pace. So it's a very manual, hand-done process. It's fun. It's very meditating. Adam actually had a chance to use this machine when he was here last year, and did some cool engine turning on it too. And I don't know how well you guys can see in the iPad, but this whole thing's moving. Yeah. Now I'm going to get the microscope set up. Just bear with me for 1 second.
Joshua, after I came to visit you at your workshop in LA, I immediately went home and started Googling where I could buy my own engine turning machine.
Oh.
Because it's you're right, it's a very meditative process. It's a you know a really interesting way to create something yourself, and really you know, the sense of accomplishment after you make one small thing, which is what I did. I made one small thing, but it was like, holy crap, what else can I make with this? And that's actually what gave me the idea to collaborate with you on doing taking my mashup prints, which I've done a couple of exhibitions of, and I think right after that is when I asked you to start thinking about a collaboration and what we could do together, and eventually I came up with what everyone is seeing here, which is a specially made print, where I don't print on certain areas of the print itself, so that it leaves more of the metal just showing, and yeah, as you can see, the silver area where Joshua is pointing right there is actually just not printed on aluminum, because the process that I use is a dye sublimation printing process, taking my photographs and putting it directly onto the aluminum print and the aluminum plate. So it's very cool. And there you're seeing the up close version of the microscope. on the print itself, that's super awesome.
Yeah, let me see how well I can do this. Thank you, Adam. Yeah, that was a great explanation. I'm trying to think too much and words at the same time. But let me see if I can get this so it's really clear what it is. So this, what you see moving, is the cutter, and then the wavy lines here are what's being engraved. And then these little pieces here are actually the lacquer from the paint that's on top of it. So unlike normally when I engine turn something, it's just right on the metal. Here I've actually got to like break through a layer of lacquer. And I actually had to change the shape of the cutter that actually makes the cut to kind of deal with the lacquer, which is a new adventure. Okay, so let me think how I can show this. I need more hands. Okay. Let's see.
It's like you need someone else in the studio with you to hold that.
Yeah. Could you hold this at the screen? And I'll come over here.
Thank you, Arthur.
Yeah, thank you.
Okay, can you guys see that?
We've lost video on that. There we go.
Okay,
It's back.
it's back. I got a call.
Ah,
Okay. Yeah, so if you guys can see that, you can see little bits of metal that's being removed. I'm just going very slowly right now because otherwise it kind of gets dizzy.
It's actually kind of relaxing even just to watch.
Yeah, it's a wave pattern, so it's.
Oh, wow, look at that.
that's really cool.
I know this question will be answered later. When are these going to be available? When is this project going to be finished, do you think?
So Adam, we've just begun the process of making the prints, and we are going to make an unyet determined amount of them, and based on how many people are interested in the project, and then and from there we'll in the near future we'll make an announcement about which charities we're going to be able to help support with the proceeds. So originally Joshua and I were making one of these for the Horological Society of New York's gala, but as you know, with everything that's going on, the gala has been canceled, and we've we've still continued the collaboration now.
Wonderful. All right, well, we'll keep our eyes and ears peeled, but what a wonderful idea, and what a great way to really demonstrate the type of work that Josh has really mastered. I've been fortunate enough to have a few goes at the Rose machine myself, and it on some level you might be lulled into thinking it's a pretty easy thing to do. You just sit down, you have the guide, but so much of it, as Josh demonstrated and is doing right now, is the pressure that you apply, that you really have to have a feel for that. And then the speed at which you're running the machine. So it seems a little automated, but it really requires like a gut feeling to do.
Yeah, there's a lot of touch sensitivity. As you can see here, this is very different. We're cutting through the lacquer, and then you can see the bright cuts of the metal underneath. This is actually zoomed out as far as I can go, but we'll go the other way, and you can kind of get an idea how big everything is by my finger. But this microscope's pretty cool. We can go way in.
All right, now I'm afraid we're going to start seeing like dust mites and water bears, like giant sized.
Yes.
So
Tardigrade, yeah. Tardigrades.
Yeah. So we have a couple of questions, and I'd like to kind of dive into them. So one question is, how much time is spent setting up the machines versus actually using it? So like, how difficult is it to set up when you're getting ready to use the machine?
Yeah. So here, I'll talk into the camera. Let's see. How do I turn it? Thank you, Artur.
There he is.
Hi. So it depends on the operation, but usually setup can be, on the Rose engine machine, it's a little bit longer, maybe 15 minutes to 30 minutes. But then on the straight line machine, a lot of the setup is on the tooling, like all the little things that go with it. So this is the straight line machine. And so, there's a lot of setting up the flatness on both machines, making sure everything's very flat. And on this machine, you have these things called pattern bars, making sure everything's correct with them. And there's a lot of things that go into it. Like these pattern bars, took me years to get right, to develop. These rosettes I had specially machined. So a lot of the setup, there's everyday setup, and then there's making your machine, your 90-year-old machine or 70-year-old machine as accurate as possible. But in general, it's anywhere from 15 to 30 minutes, and then my dials are usually, I'm working on them for days. On the Rose engine machine, usually it's a few hours, the engraving I do on here, and then the engraving I do on here on the straight line machine could be for a week if it's the infinity weave, a day if it's the basket weave. And if it's all right with you guys, I can show sort of making the basket weave, which is a really cool pattern. So I'll get the microscope set up, and I'll show that on the screen.
Okay.
Unless there's any other questions I can answer.
A couple of other questions, but one specifically, touching back on what Adam said about doing some research into getting his own machine. Someone would like to know what the difference is between a cheap Rose engine and a much more expensive one, or a new one versus a vintage machine. You seem to have you've got a couple of really vintage pieces in here that you're using. Is there what considerations, if folks want to do their own, what should they be looking at?
Yeah, so first off, there's only really one person that I'm aware of in the United States that makes Rose engine machines, and it's David Lindau, and he's a good friend of mine. And he makes two versions of a machine. One machine that maxes out at around $25,000, that has like plastic rosettes instead of bronze rosettes. But that doesn't really make a difference, but it's still a great machine. And then he has a machine that's about $100,000 that is really beautiful. There we go. Thank you, Atom, for the link. And I got this. Sorry. Move the TV with the cords. You guys ever get your Rose engine machine stuck in cords? I have a problem all the time.
Yeah, it's a problem.
Yeah.
I wish.
Yeah. So, okay, sorry, back to the question. So, yeah, new machines anywhere from $20,000 to $100,000. In terms of the quality, they're great, amazing machines. And same with the old machines. The old machines, you can get machines that were made by companies that are okay, and then there are some companies that are better than others. So a lot is figuring out which machines are the better of the antique machines. And then it's how to master that individual machine, whether it's new or old, all the idiosyncrasies of that machine, the learning curve, everything that goes with that particular machine. Like any of the tools in my shop. You know, there's actually acquiring the knowledge to know which machine to get, and then the skills to do it. So if anyone's looking for a machine and wants to jump into the hobby, David Lindau is the place to go. Antique machines are getting harder and harder and harder to find. The Swiss buy them up and lock them up. They don't want other people having them. And in the United States, you know, there's just fewer and fewer machines that are available all the time. Like, you know, like maybe once a year something pops up, but even that is optimistic now. But if anyone ever has any questions on that, you know, you're welcome to email me. I love talking about machines, and I love helping people find machines. And sometimes I end up buying them, and it doesn't work my needs. Like, I've sold machines to jewelry makers because they weren't set up for watchmaking. And yeah. Let me show you guys the straight line machine in action. Just
Joshua,
give me a second here.
while you set up there, Joshua, I just wanted to let everyone know that I was a little derelict in my duties when I was introducing Joshua earlier. He's well known for a basket weave pattern he calls the infinity weave, which is, shall we say, a ridiculous undertaking. If you think that engine turning a dial is difficult, he essentially makes a basket weave pattern within a basket weave, which, to my knowledge, is something that I don't know that anyone else has ever done. Is that fair to say, Joshua?
Yeah, no one's ever done that pattern before. They've done the basket weave, but I spent a lot of time trying to figure out how to kind of take it to the next level. And first I made the tools, and then I had to see if I could actually do it, and that took a long time. I'm just going to sit down my phone so I can get the straight line machine set up, and then I'll kind of show you that machine in action. Just hold tight for 1 second.
Yeah, while you're getting that set up, I will show the infinity weave on my screen.
So I've had the opportunity to work with Joshua on a professional level, where I've photographed some of his watches for his website, and getting access to up close and personal to his incredible watches. Here on the screen there, you're seeing within the sub dial is where he does his infinity weave, and on the regular part of the dial there you see the standard the basket weave, which he does with the straight line machine that he's setting up now. Kathleen, do you have a closer shot of the infinity weave there?
Yeah, let me find it. Give me 1 second. Give me 1 second.
Even at this level, though, you can see this is insanity in 10 cities that I'm looking at here.
Yeah,
wow.
That's on the sub dial there.
Wow.
Yeah. So this is the infinity weave pattern. So it's a basket weave within a basket weave, which is completely insane on level of detail. So it's really beautiful work. Adam, do you want to talk about? I know you've done some of the macro photography for Joshua's work, and you can kind of walk us through this a little bit if you'd like.
Yeah, sure. Is that we're still seeing the gold dial, the gold cased watch there?
Yeah.
Yeah.
So getting up close and personal and doing macro photography of watches with details like these, oftentimes you'll get to see things that the normal human eye cannot see, which is really interesting and makes these particular dials and hand engine turned with machine dials really interesting, because you get to see there's slight imperfections as far as in the metal itself as he's using the machine. There's tool marks and there's little slight variations and line thicknesses sometimes, and it's just a a thing that you don't see with your regular eye. And if Kathleen, you could go to any sort of closer photo, that'd be cool.
I have a closer one than this, but let me check.
Okay.
I can zoom in on this if that's
sure. And what's really interesting about that is that in today's culture of, you know, everything must be perfect and you know, retouched and photoshopped, and it must be smooth and beautiful and straight and everything. It is to see the handmade with a machine dial up close with your eye is just it brings this tactile experience with it, and I think that's part of what is really interesting about engine turn dials. And of course, this particular setup of dial, as if you go on any internet forums that talk about engine turning and guilloche, as it's also called, is you'll see a lot of people saying, "Oh well, you know, anyone who's done an engine turn dial like this, of Breguet or um, George Daniels, have all done a very similar aesthetic." And that's, I think, A, because it's really beautiful, and B, because it's a well-balanced dial. And you can see on the outer edge where he has the California plate and the engine turn plate, there's a different pattern there than there is on the interior and then also the subdial. So I saw in the Q&A, somebody asked how many pieces are on these dials, and I think what is this a 5-piece dial, Joshua, or maybe he can answer that in a moment.
Yeah, I have on the dial. There's 1, 4, 5, 6, 7. There's about 7 different parts on there. There's the chaptering, the 3 plates. The subdial is a separate part. The infinity weave, I do that as a separate part, and then we laser weld it, spot weld it from behind. And then there's some hidden screws as well, but not counting those. I think I'm ready to go.
Okay. Stop sharing my screen then.
So
Spotlight.
we're doing our best here to show microscopic stuff, but what you can see here is a zigzag line. So this is sort of how a basket weave starts. It's all geometry. And Artur, would you mind holding the camera again, and I'll show it as it goes? But basically, I'm going to index and phase the machine to get these different patterns. There we go. All right, so you can kind of see how small we're talking here. Like, this is my fingernail, and I don't have giant fingers. And this is actually with the camera zoomed out all the way. You can see this is on silver now. So we're making the different parts of this basket. Just moving away the chip. And we're going to try to go until we get a square.
So how long does this process typically take? Did you say for like to do like a one of the sections of the dial and the full, like just the basket weave, not the infinity weave, but just that, like the dial that we were looking at before, the part of it that's just a more traditional basket weave? How long does that take you to do?
About a day of work, 3 or 4 hours. So here you can see how we kind of turn that one line into a square. And then And then here, you'll see the next part of the basket. You can see we've added that line. I hope you guys can see this okay.
Yeah, I think we can see it. It's just it's, I think while you're actually creating the line, we're getting some there's like a little bit of reflection, but we can see it when it's there. Yeah.
Well, it's actually going, the actual tool reflects the light. It makes it hard to see the cutting.
Yeah.
As it's going. And then we can go way farther in. Let me get this a little less blurry.
Wow.
Yeah.
So
you can see everything when you get this close, and you can see my nail, how tiny we're talking right now.
That's very tiny.
Yeah. And then, so for reference, we're like, here's my finger, you know, like what you guys just saw up there is like just a tiny little segment. You can probably hardly see it in the camera, but it's, you know, half the size of my fingernail.
Yeah, it looks just like a little scratch in the middle when you
yeah.
I've got a couple of other questions.
Sure.
Like to take them. One person asked, has engine turning ever been done to the plates of a movement?
Yeah, lots of brands do that. Benzinger, if you ever heard of his watches, he specializes in doing skeleton watches with engine turning on them. FB Journe has, I think it's CNC done, but he has engine turning on the background of you know, his gold movements. You can see that underneath the plates and bridges. Lots and lots of people have done it on the actual movement.
Okay.
I don't like to on mine. Like I like to keep things separate. That's just my own personal taste. But I've done it in the past. I've tried experimenting on movements before. You know, it has its own challenges. There's a lot of recesses and things for the wheels and plates and bridges.
Okay. What is your favorite material to engine turn? What's your favorite to work with?
Gold for sure. Like gold's like a magical metal. Like it's obviously it's valuable. It's very, very dense, but it's also really a pleasure to engrave, especially either rose or yellow gold. White gold is more challenging. It's a lot harder because of the palladium inside of it. But rose and yellow gold, 18 karat, is really, really smooth. It's like cutting butter.
Nice. We have one more question about engine turning. It's engine turning is an endangered craft in the UK, with endangered in quotes. How is it doing in the US?
So there's a pretty decent resurgence. Once again, thanks to David Lindau. You know, he's the head of sort of the engine turning societies. There's engraving on metal, which is engine turning or guilloche, and then there's the ornamental turning world, which is actually much larger than the engine turning world. Ornamental turning is turning wood, is cutting wood on these Rose engine machines. And there's quite a few woodworkers that make beautiful boxes and other objects, furniture, using the Rose engine machines. So, you know, like I'd say it's probably, you know, for every 50 people doing wood, there's one person doing metal. And, you know, we're talking of a community of maybe like 200 people, period, in the United States, and maybe 1,000 people in the world have engine turning machines either for wood or metal. So it's pretty small, and everyone kind of knows everyone else. And, you know, we have symposiums and, you know, like I have I know everyone that has the same straight line machine as me in the United States, as far as my knowledge, unless one's being dusty in some basement somewhere. And, you know, we'll talk about the different things about our individual machine, because there's only 5 of us. There's only 5 of us out there that have this machine here. Like, they're just super duper rare. You know, a lot of them are in Europe and a lot of them are in Swiss, you know, factories locked away, and a lot of them have been scrapped, unfortunately. In the 50s and 60s, a lot of them were used to make jewelry, to make cigarette lighters, boxes, all sorts of things. And when those markets died, there was no use for the machines, and the watch world was kind of dying too. So unfortunately, a lot of machines were just scrapped and gone. Artur just finished making a pipe for a seconds hand.
Okay.
And there's no way you'll be able to see it
Huh.
because it's absolutely microscopic. But
Wow. That's tiny.
yeah, there's a spot in my finger and it's smaller than that.
Wow. Quite another question about the machines. Did you choose the machines that you bought, or did you just end up with them because that's what was available?
You know, when most people get insomnia, I'm sure they watch TV or a movie or something. I scour the internet for engine turning machines and other old machinery. So I'm kind of always looking, and I'm always contacting people and trying to be in a good network of people that have machines. And so I was lucky enough to have one set of machines, and I sold it. Someone actually pretty well known. He's a good friend of mine. And then I bought the second set of machine a year later, you know, realizing that it was more suited for what I needed for, like, sort of this like micro precision, tiny engine turning. So yes, I did choose these machines. I had options of other machines, but I specifically wanted these machines. Here's something kind of neat to think about. This machine was made in the 1930s, and in England, and people weren't super large there. You know, like the average height was maybe like 5'5", 5'6". I'm 5'8", and so when I'm sitting and working at this machine, I'm often doing things over here, and because of its size, literally the size of the machine, I can be sitting and I can reach my hand over to here while I'm sitting. And as a result of that, I can work a lot quicker and a lot more comfortably. Other machines are massive and you kind of have to just like stand up every time you want to go over there. You know, Atom was super tall, so he could like easily reach over to the other side when he worked on here. But there are some really massive Rose engine machines where literally after every cut, you've got to stand up and walk over. And when you have to sit up and stand up a few hundred times, that gets pretty exhausting. So that's one of the reasons I got this machine. It's a very small, compact machine. And then this one, I don't know if you guys can see it, but it's extremely heavy. It weighs about 800 pounds. And the heavier the machine, the more stability it has, the more rigidity. And if I had previously a smaller machine, and it could do wonderful work, but for the really precise stuff, it was thinner and smaller, so it would vibrate. And that was too much for me. And you'll see over here, you know, you've got this little lathe on a big table, and it's all for vibration. Whole same idea. Like this lathe is super heavy. This is a few hundred pounds, and then this bench is even more, because everything has to be very stable for precision work. You know, my CNC mill, it doesn't look like it, but it weighs, I believe, 1,500 pounds.
Wow.
So yeah, everything's got to be very, very rigid. You know, this little machine, you know, this is, I think, 120 pounds. Like, this is a solid cast iron base. Everything's got to be very, very solid and rigid. And so these are the things you kind of look for in whatever machine you have. You know, this machine weighs 500 pounds, but if it weighed 200 pounds, then the whole thing would be shaking while you're using it, and that wouldn't be good.
Is there,
Let me show you guys.
show us some of what Artur is working on?
Yeah, good segue. So let me see if I can get.
I am a fan of this engraving work, so I'd love to have a look.
I'll try to get in here. Let me see if I can. So he's doing a buckle for me right now.
Oh,
But
nice.
he also let me see if I can. I don't think I can zoom in more on this.
On the phone.
Yeah, but what we'll do is he's brought some of his really cool stuff to do, and
Okay.
I'll put it under the microscope and we'll take a look at it.
Let's do
Just
that.
put a loop in front of it. Put a loop in front of your lens.
Oh, that's a good idea.
Try
Maybe
that.
that one.
And then we do have one other question while you're doing that. What do you think about bracelets for your watches and watchmaking versus the more traditional leather that you usually use?
You usually use leather because that's just what I like and what most of my customers like. Haven't had someone yet. We can't really see through there.
Yeah.
We haven't had someone yet request a bracelet, but you know, I don't make my own straps and bracelets, so I'd probably outsource for that. But I guess they could look cool.
Yeah, I mean,
was it Longa put out there Odysseus with that nice bracelet?
yeah, I think integrated bracelet could work on it. It's just that the aesthetic that you usually go for is classic, and I think personally would be more suited to a strap, to a more traditional kind of leather strap than to a bracelet, because most of your pieces don't read sporty to me at all. So
yeah. What's neat though, I noticed that I believe Rolex in the 50s had a few watches where the bracelet actually had engine turning on it, and then it matched the pattern that was on the dial. So it was like this continuous pattern that went from the bracelet to the dial, and that was really cool. That was really interesting.
That would be interesting. I think seeing things like that where the I think it would be too, I don't know, it would be too jarring to see just like a plain bracelet on something that has such intricate detail on the dial, you know, like just a standard
Yeah.
metal bracelet would just look weird. I mean, but maybe
Yeah.
to do some engine turning on some gold bracelets. That might be cool.
Joshua,
Yeah, I love experimenting on stuff.
How do you choose the movement that you're working with? And you mentioned something earlier about, are you working on your own movement at this point?
Yeah. So I chose the UWD movement because I thought it was the most beautiful hand wind movement that I could find, that I could actually buy. And for this first Infinity series, I just wanted to focus on making a really beautiful dial and that serial plate on the back. And then I can't reveal all my projects, but here's like some early just kind of playing around prototype parts for my first manual wind movement. I've actually scrapped this design. I'm working on something else now, but you know, people think that dials are kind of like an easy process, but the dials I make are extremely complicated. I'm using all these different machines. And so when it came time to make watch components and watch parts, it's not that bad. Like, it's not as scary or as difficult as I thought it was going to be. And that's because of all the time I've spent learning all these machinist skills for my dial making. Interesting enough, the most challenging part of a watch are the pinions and pivots on it. It's a part that you can't really see in a watch. This is from the UWD. Hold on, let me set this down one split second. So, trying to look through my camera and pick things up. So what I'm holding on to everyone's seen this, everyone's aware of this, but what I'm holding on to, you can see the watch wheel itself, and then there's this pivot pinion on there. That's actually the hardest thing in the whole watch to make. It's an unseen part, but it's, no pun intended, absolutely pivotal. Like maybe that's where that word came from. You've got to.
Ooh.
It was a solid dad joke, either way.
Yeah,
Yeah.
seriously, I'm filing that away.
That was a
Use
pivotal
Yeah,
joke.
yeah. No, my poor kids, they're used to it all day long.
Wow.
Yeah, so the pivot is the long skinny part, and the pinion is the part that looks like a gear. That's the steel part of the wheel, the complete wheel. The wheel is usually made out of brass, and that pivot pinion is just extremely difficult to make. There's hardening processes. If you look at George Daniels' watchmaking, a significant amount of the book is dedicated just for those parts. They're extremely challenging. They take a lot of equipment, and but it's a really fun challenge, and I'm really enjoying, kind of this transition stage, going from a primarily someone making dials to also making all these movement parts as well. And hopefully soon I'll have some cool stuff to reveal for that and other projects I'm working on. There's always
looking forward to it.
a lot cooking here.
Is your intent to, I mean, this, of course, we always, we hear a lot about, people trying to revive watchmaking, especially given that the U.S. used to be a massive, massive force in watchmaking in the world. Is your intent to eventually produce like as much of the movement in your in-house or in the U.S. as possible?
Oh yeah, big time. I think that's the goal of every U.S. watchmaker, and it's when I picked this up 8-9 years ago, that was my intention from the start. And I've mastered all the equipment and put together a great team and have the skills, and still developing the skills. It's always a learning process, always figuring out different things and different challenges. So I'm just trying to find good lighting.
Yeah.
And I definitely want to bring back the American watchmaking scene. We had such an incredible industry here. You talk about in-house, the main companies, Waltham, Hamilton, Elgin, they literally did everything under one roof. The Swiss were able to knock them out of business because they would have a different company would do every different part of a watch. And so the Americans couldn't compete with that. And now it's interesting. Now in-house has become the thing where, Patek and these other companies are trying to do everything under one roof. And that's what we were doing here for almost 100 years.
Yeah.
And that disappeared. The last American watch company was Hamilton in 1969. Waltham was out in the 50s, Elgin too. And so since then, we've been trickling back. Roland Murphy, plenty of makers, and now it's a really exciting place for watchmaking in America again. And my goal is, to make everything I possibly can inside of the shop. And, we've made huge progress with that. We're making a significant part of these watch projects that I'm working on in-house right here, including the pivots and the pinions. And it's really, really exciting. A lot of other independents, they'll design a movement, outsource it to someone else, and then they'll come into their company just for the finishing. A lot of independents do that. There's only a very few independents that actually make the parts and finish them all under one roof, and that's what we're aiming for.
Someone, Matt asked if there is an undercut on the pivot that you were showing us before, that you had on the that you're showing us the part on the table. We want to know if there's an undercut on it.
Undercut? I mean, it's what I showed was the center wheel with the cannon pinion. So the cannon pinion has sort of like a inward cut in the middle of it, which you kind of crimp, and that grabs. Oh, sorry, the cannon pinion goes on top of that. So no, this, I'm not sure what you meant by undercut, but no, this is a straight pivot. The center wheel has like the thickest of the pivots, and then the cannon pinion kind of crimps onto that, and that has, I think, what you would call an undercut.
Okay. The other couple of questions, will you be finishing the movement as well when you're doing your own movements? Will you be doing finishing your own movements as well?
Oh yeah, for sure. Yeah. I do all the engine turning, and I really specialize in making a lot of the parts using the CNC machine. We all are capable of using the lathe. There's 3 of us, Artur, myself, and another person. And, Artur's finishing skills are on another level. So, we've all kind of developed different skills, and we all have different things that we use inside here. Like, I can't hand engrave. It's a completely different art with years and years of practice than engine turning. But engine turning is much closer to machining. And so that's sort of where my experience lies. I'm also the guy that takes out the trash and does the renders, and, like, we're a small business, so everyone does everything. I could be working on a $40,000 watch, and then, I'm the one that sweeps the floor before we go. So it's exciting having your own company and doing things like this. But yeah.
So we are almost at the top of the hour, and I know you wanted to get to showing a couple of Artur's.
Oh yeah, he's working on some super cool stuff.
We can go.
Artur, could we show your watches? Stuff you're working on?
Hope everybody can stick around for another few minutes so that we can see some of this, because Artur's work is, I would classify it as mind-blowing. So I hope you guys will enjoy seeing it.
Yeah. Artur and I have been working together for about 3 years now, and he has his own company where he does really cool stuff. Okay. We'll try to get this under the microscope.
Hello.
But this is, no one's seen this before. I have to ask him very nicely to see his work. This is made out of blue steel. It's a dragon, and then he's inlaid inside of the dragon 24 karat gold fish, and he's engraved the whole thing. He blued it with the gold inlays in there, which I don't think anyone's done before. We did it like it was like buried in brass, so it was cool. It was done like the dragon emerged. Let's see if we can get underneath the microscope and actually see it.
Awesome.
I don't know if my mind can get any more blown. Maybe I should look away.
Yeah.
To be fair, I did I also had the pleasure of coming to the workshop with Atom last year, and got to see some of Artur's work up close, and it's pretty great stuff. Hopefully we can get the microscope to show the detail work, because it is it's incredibly detailed.
Yeah, this is the
Like
coronavirus world, trying to get in the microscope. I think needs to come up more so that we can get it
not quite in focus.
Joshua,
yeah, thanks everyone for your patience.
Yeah,
Joshua, what's the name of Arthur's company? Does he have a website as well? Someone asked.
Yeah, I mean his Instagram. Oh, there we go. Nice. Okay.
getting some window light reflection, so if you could maybe stand to the side just a little bit. Oh wow.
Okay, yeah. Oh, stupid window lights.
The window.
Who needs natural light anyway?
Yeah, stupid windows. Get out of here with your clarity and ability to transmit light.
Wow.
Okay, we're almost there.
Even so,
Almost there.
it's still incredible. I should point out I didn't have a lot of mind to begin with, so to blow it up right now is not going to serve me well, but I'll continue to look. I can't look away.
Yeah, I'm his biggest fan, so I apologize, Artur, I'm
Amazing.
speaking for you. But what you can see here is, this is a blue steel dragon, right? That was hand engraved, hand carved, and then blued, just like hands are blued. There we go, beautiful. And then these koi fish are inlaid into the dragon. And then over here, this is a Japanese dragon. So this is Kyoto. And he's done this enameling, this green enameling on here.
Yeah, his enameling work is really, really beautiful. There were a couple of pieces that I looked at when I was visiting the workshop that it's just like the colors and the like depth that he's able to achieve in the enameling was really beautiful.
Yeah, he's a true artist. There's no question.
There's a
So
photo.
this is like Japanese mythology,
his...
and this is like Artur was just telling me that this is these black lines. There's 3 different layers of enamel here: the green, the yellow, and the black. And then over here is, this is the ocean, yeah? Waterfall. Ah. The fishes are going up and then they become the dragon. So this is relating to Japanese mythology.
Yeah.
Yeah, so Artur, he works for me a good chunk of the time, and then he also makes these wonderful watches. And, some people are, like, in Switzerland, you never hear about like the individual watchmakers who works for a company, but like, my goal is that, Artur can have his successful company and I can have mine, and we can do these incredible projects and work together and, like make these beautiful works of art.
Yeah.
And, I don't hide that I have like this incredible talent working for me. Like, people should know who works for the companies. It's not just the guy whose name that goes on the watch.
Yeah, agreed.
Yeah.
So Artur's Instagram is in the chat. Adam Moore posted it, so you guys should all go follow him right now. There's a photo of this watch, of this dial on his Instagram as well. Great. So I think we have one more question, and I don't know if you'll know the answer to this, but someone David asks, what about Southern California in particular do you think attracts all these great American watchmakers? Because there are, Cameron Weiss and David Walter, and there's a few other folks in Southern California. I mean, obviously, you guys have some pretty sweet weather, but is that the only thing, or is there like a community of watchmakers that have kind of banded together? I mean,
well, I mean, there's a few different reasons. There's really there's a lot of industrial properties here. There's the whole aerospace engineering industry, and so that means we're well suited to make anything here. And there's machinery here, and there's machinery companies here, so it's easy to get machinery. I was almost ready to move into an industrial place right before all this Corona stuff hit, but there's plenty of facilities here. The weather's beautiful, and so there's a lot of people in California, so we've got a good percentage of the United States, so yeah, maybe those things all play into it.
Well, I think the point that there is a lot of I think people kind of forget that there's so much aerospace industry there, so it does make sense for industrial production of anything that there would be a lot of facilities in place and equipment and stuff kind of at the ready to help manufacture other things besides aerospace equipment.
Yeah, absolutely. Like I'd say like maybe a third of my machines, came from the aerospace industry. We were being used there. Yeah.
Okay, well, thank you so much for your time. Please thank Artur for us as well. I don't know if he can hear us in the background, but we really appreciate you sharing this with us. Also, Atom has posted a couple of the macro shots that he's taken that we showed a couple of them here. There's a few more photos where that came from on both your social media and Atom's. So if people want to get closer looks at the engine turning work and the dial work, there's plenty of it on Instagram. So
yeah, and if anyone's welcome to visit when all this Corona stuff is over. It's very hard to show the micro through Zoom and bandwidth and phones and stuff like that. But the best way to experience is in person. So my workshop, anyone always has an open invitation to come and try machines and see interesting things.
Awesome, thank you so much. And as usual, all of this session has been recorded and will be on our YouTube channel if people would like to watch it again. Okay, thank you very
All
much.
right,
So
thank you very
yeah,
much, RedBar.
Thank you so much,
Thank you,
Josh.
guys.
You're the man.
Thanks,
Be
Joshua.
safe, of course, and please say hi to Artur for me. I haven't seen him in a
Okay.
while, so keep up the good work, gentlemen.
Yeah.
All right, thank you very, very much.
Thank you.
Take care.
Bye.
All right,
everyone.
bye.